find the following integral: cos x, integral of x cos x dx, the integral of x squared sinh 2 plus x cubed dx. So cos 2x dx, if we integrate that, we first of all have to say that cos 2x probably has come from sinh 2x. So if we differentiate sinh 2x, we will get 2 cos 2x. We've got 2 times too much, so we need to put a compensation in front of that by putting a half. So the integral will be a half of sinh 2x, and don't forget to add in the constant of integration. The integral of x cos x dx, well, this is a product, so it probably needs to be done by integration by parts. So the integration by parts says that u dv by dx dx is equal to uv minus the integral of v du by dx dx. So we're going to let the u be equal to x, and then if we differentiate that, because we'll need that here, we'll get 1. And we're going to let dv by dx be cos x, and if we integrate that, we're going to get sinh x. Right, so the integral of x cos x dx is going to be u, which is x, times v, which is sinh x, minus the integral of cos x times 1 dx. So we're going to write that out again, but we won't need to write in the 1 here. So that's going to be x sinh x, and then we're going to have to subtract sinh x, because the integral of cos x is sinh x plus c. So we've got x sinh x minus sinh x plus c. Okay, the final one is an integral of x squared sinh 2 plus x cubed dx. We could do this directly, but just to show you how integration by substitution works with this, by substitution, we're going to let u be equal to u2 plus x cubed. If we differentiate that, we're going to get 3x squared, which means that dx is du over 3x squared. So my integral, x squared sinh of 2x cubed by dx, well, that x squared will cancel out with that x squared. And then we still got the 3, so it's 1 over 3, which I've taken out of the integral sign. Sinh of my 2 plus x cubed, which is now u. Right, this is very easy to integrate, so this will just be 1/3 cos u plus c, but u is equal to 2 plus x cubed, so it's equal to 1/3 cos 2 plus x cubed plus c. Now, you could have done this directly without using substitution. Okay, this has been a video how to show you how to integrate hyperbolic functions. I hope you've understood, and I thank you very much for watching.